Welcome back for Chapter 1, Lesson 9, Applications of Proportions. So our objectives for today are to use proportions to solve problems involving geometric figures, and also to use proportions in similar figures to measure objects indirectly. So, to get started, we're going to talk about the vocabulary term of similar figures. And similar figures have exactly the same shape, but not necessarily the same size. So if you look here at this triangle ABC and triangle DEF, they have the same shape, but they don't have the same size. It's almost like this one right here is a shrunken down version of this one here, or this one is a blown up version of this. So they're the same shape, but they're not the same size. So whenever you have figures that are similar, you would use this little line like this. So this means, and these are the symbols. Triangle ABC is similar to triangle DEF. Okay, so they have the same shape, but not the same size. So whenever you have shapes that are similar, what they have is they have corresponding sides. And sometimes you can tell by looking at it, but you can always tell if you look at the letters. Now this statement right here actually tells us a lot of information about these triangles. The first thing, it tells us about its corresponding sides and its corresponding angles, okay? So what we're gonna do is we're gonna list all of those. The easiest and straightforward are the corresponding angles. So what that means that the angles have the same measure, like the same degrees. So like if this was like a 30 degrees, then this one would be 30 degrees. So you can tell by the way that this is written. So when you have the first letter A and the first letter over here being D, that means that they are congruent. They are the same size. So we could say the measure of angle A is equal to the measure of angle D. Oh, this probably should have been a capitalized A, I'm sorry. The measure of, yeah. So that means that they have the same measure. So if this was 30, this one would be 30, okay? And yeah, so, and then you could tell the next one, B and E, the measure of angle B is equal to the measure of angle, it's the second letter, E. And then we could do the next one, which the third letter in the sequence is C. So the measure of angle C equals the measure of angle F. Okay, so they're equal to each other. Or you could say they're congruent. So whenever you're talking about things being equal, you use the measure, this angle, and then you say the particular angle. Whenever you're talking about it being congruent, you would just say, if we were going to write this same statement, it would be angle A is congruent to angle D. And you just use an angle and then you use this congruent, okay? For this one, we would say angle B is congruent to angle E. And then lastly, we would say angle C is congruent to angle F. Okay, so those are all the corresponding angles, okay? It's just very straightforward, the letter. Now, the corresponding sides are two sides that are similar, but they're not exactly the same length. So here, one set of corresponding lines, and you can tell by looking at it, it would be the first two letters in the sequence. So AB and DE, those would be corresponding sides. And you'd set this up as a ratio. So we go AB, that would just be line segment AB, over line segment DE, okay? Is equal to another set of corresponding sides would be the second and the third letter, BC. and you would go do the second and third letter over here, EF, and those are corresponding sides. So BC is corresponding to EF. And so BC is corresponding to EF. And the ratio between corresponding sides is the same. And then there's one more, and it is the first and the third. So AC, and then the first and the third here, DF. So AC is corresponding to DF. AC and DF. And so that means that their ratios are all the same. And if I wanted to just give you a real quick example of what that could look like. Let's say this is 1, this is 2, and this is 3. What I'm going to say is this figure is 3 times as big as this one. So that would mean I take this and I multiply it by 3. So 1 times 3 is 3. And that corresponding side is 3 times bigger. Over here, BC, we go, it's 2. 3 times bigger would be 2 times 3, which would be 6. And then pink, it has a length of 3, and if it was 3 times bigger, we go 3 times 3, which would give us 9. So when I say we multiply each of these sides by 3, what that's called is a scale factor, okay? So the scale factor is 3 times, or times 3. Well, we'll look at that just for a second. So if you have this, and then we put in those numbers. So AB is 1, and DE is 3, and then BC is 2, and EF is 6, and then finally AC is 3, and DF is 9. So we have all these, but if we were to reduce them down, we can't really reduce that, but what goes into both of these numbers? 2. 2 goes into 2 1 time, 2 goes into 6 3 times, right? And what about these numbers? What goes into both of them? 3. 3 goes into 3 1 time, 3 goes into 9 3 times. And so if you see, they all end up being the same, and that would be the scale factor from this triangle to this side, this triangle right here. So they have the same, it's the same ratio, they end up being the same number. Okay, cool. So you can use it says you can use blank to find missing links in the similar figures. So you can use corresponding sides. And the next problems that we're going to look at are going to deal with this. Okay, corresponding sides. All right, let's look at some examples here. So example 1 would like us to find the missing measures in similar figures. So find the value of x in each diagram. And it's giving us this statement. And remember, this statement tells us which angles are congruent, and it tells us the corresponding sides. So, so there's a lot of different information here. So let's go ahead and look and see what we have. So we have a RT right here. So that's the first and the third. Do we have a BD? And we do. Okay, so we can write RT over BD. RT over BD. And I'm just going to make that side pink. Okay, so that's one set of corresponding sides. And I put the, like, this one's smaller and that one's bigger. So I put the smaller information on top and the bigger information on the bottom, okay? It doesn't matter which one you put on top and bottom, just as long as it's the same for both ratios. And you'll see what I'm talking about right here. So what else do we have? We have RS. RS is the first and the second, which would mean the first and the second would be BC. And that's what we have. So we put this triangle RT first, so we need to put RS on the top as well. So the information from the same triangle needs to be on both the top. I mean, it has to be on the top or they both have to be on the bottom. So you can see here, what do we just find? RS, and so the next would be BC, and that's going to go on the bottom, okay? So those corresponding sides there. And then once we do that, we're just going to, so this is writing the statement in symbols, okay? So I would like you to do that on your homework, and then you're going to substitute in the values. So RT is 5 over B, that's a D. BD is 12 equals RS is 8 over BC is X. And then what we have here is we have a proportion. Remember we practiced solving these 2 different ways in the last lesson. The first way was just, you know, getting X on top because you can never figure out what X is when it is on the bottom of a fraction. And then the second way was we did the cross products property. So that's what I want to do now is just do the cross products property. So we're going to go here, 5x, 5 times x is equal to 8 times 12, which I'm pretty sure is 96. And then we're just going to get x by itself, divide both sides by 5, and there we have it. X is equal to 96 over 5. So we probably want to put this as a mixed number since we're talking about feet. And that would be that would be 5 goes into 96. Well, it goes into 120 times, so it would go into 95. It would be 19 times with 1 left over feet. Okay? That would be our answer for BC. Okay, so let's look at the next one. This is a 2 trapezoids, 2 quadrilaterals, but it gives us the same information, right? So what do we have? We have this AB here. And do we have, so we have AB, we need to have the first and the second, which would be WX. And we do. So let's go AB over WX is equal to, what else do we have? BC, that's the second and the third. Do we have the second and third XY? Yes, we do. So let's go BC over XY. And then what we're going to do is just, we have our proportion, right? We want to figure out the value of X. Then we just substitute the numbers in. So AB is 5 over WX, which is 7, equals BC, which is 2, over XY, which is X. And then, like we just did, we're going to use this proportion to figure out what X is. So we can just use the cross products property. And we have 5 times x, or 5x, equals 2 times 7, or 14. And then we're just going to get x by itself. So we need to get rid of this 5. It's related to x through multiplication. So then we just divide both sides by 5 and end up with x equals 14 over 5, which would change it to a mixed number since we're talking about inches, would be 2, 5 goes into 14 2 times, and with 4 left over. And that would be our answer. Ooh, all right. So now I want to give you a chance to try C and D on your own. So it is time for you to go ahead and pause your device, work out those 2 problems. Make sure that you write it with symbols like this. You do it just like I did. You write it just with using the letters and the symbols first, then substitute the values in, and then show your work. Okay? So C and D, show all your work, and I will see you in a little bit. Okay, go ahead and pause. Okay, I'm back. Let's see how you did. So, what do we have here? We have this statement, triangle MNP is similar to triangle STU. And so whenever we have this, we know that there's 3 congruent sides. M is congruent to, not sides, angles. Angle M is congruent to angle S. Angle N is congruent to angle T, which means they're the same. And angle P is congruent to angle U. But we also know the corresponding sides, and that's the information that we're going to use here. So when we look here at MN, I'm just going to pick this side. MN is the first and the second, which means it's got to be ST, which we have. So great. I'm going to put this triangle MN over ST. And then what do we have here? MP. That's the first and the third. Do we have SU? We do. So we can go MP over SU. Okay, that's in symbols. Then you would go ahead and you would substitute in the values. Just ignore that right there. So MN was 6 over ST is 4 equals MP 14 over SU, which is X. Okay, so now we have our proportion here with the numbers. We're ready to solve. So let's just go ahead and use that cross products property. We have 6X equals 14 times 4. Not quite sure what that is. 14 times 4. Whoopsie daisy. 4 times 4 is 16. Write the 6, carry the 1. 4 times 1 is 4 plus 1 is 5. So 56. Okay, great. And then we're going to get X by itself. So use that division property of equality. 6 divided by 6 is 1. We end up with X. And then we just need to simplify that. So what goes into both of these numbers? I'd say 2. 2 goes into 6 3 times. 2 goes into 56. I'm not sure. 2 goes into 5. 2 times 2 times 2 is 4. Take away 1, 6. Oh, wait. 2 goes into 16 8 times. 8 times 16. Okay, no remainder. We're done. So it goes in 28 times. So we have our answer 28 over 3, which is equal to 3 goes into 28 9 times, because 3 times 9 is 27, with 1 left over. What are we talking about? Centimeters. So that would be our answer there. Okay, so if you got that one right, great job. Let's go ahead and see how you did on this last one. Man, what is this? 1, 2, 3, 4, 5, 6, a hexagon, 6 sides. Okay, so the same is true. This is similar to that. Let's see what we have, KJ. So KJ is the first, second, third, fourth, the fifth, and the sixth. So that means we need the fifth and the sixth here. 1, 2, 3, 4. Wait, can I count right? What happened? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Why is there an extra letter in here? Okay, so J, what does it start with? F, G, H. Okay, there's no I. Okay, that's the problem. Okay, so that doesn't exist. Okay, sorry about that. Okay, what were we looking for? KJ. KJ is the first, second, third, fourth, and fifth. So it's the fourth and fifth. First, second, third, fourth, and fifth. So QR, do we have QR? We do, it's right there. Okay, so we're gonna go JK. So JK over QR. All right, and then what's the other one? So this was K or JK, and then we have GH. So do we have, that's the first, second, third, second and third. So that would be NP. Do we have NP? We do. Okay, so we can write a proportion because we have 2 sets of corresponding sides. Okay, GH over, what was it? GH for NP. And notice that these are corresponding sides, but also that on top, it's the same figure. So JK comes from this one, GH comes from this hexagon, and then QR, the stuff on the bottom, both comes with this one, okay? So now let's go ahead and substitute the values in. So for JK, that is 2 over QR, which is X, equals GH, which is 4, over NP, which is 6, okay? So this is our, hopefully you got this. If not, change it so your notes so that they have the right information on there. And then we're just going to do the cross products property. 4 times x, or 4x, is equal to 2 times 6, which is 12. And then we get x by itself, which means we divide both sides by 4. And there we have it. 4 divided by 4 is 1. 1 times x is x. And 12 divided by 4 is 3. And we're talking about centimeters. So that's how big x is 3 centimeters. All right, if you got that right, if you got both of them right, you are awesome. That is amazing. Yoku de kimashita. You did a great job, and we will see you next time. Goodbye.